In this video, we are going to look at linear inequalities. So, let's get started. So here we have this graph of a function, f of x equals 3x plus 3. So, exercise 1 goes, use the graph to determine that with which values of the variable x, the values of the function f of x are negative. So, we can mathematically express it like this. So, if we look at our graph here, the values on the x-axis represent the values of the variable x, and the values on the y-axis represent the value of the function. So, as we can see, the graph of the function crosses the x-axis here at -1. So, it's called the root of the function, since the value of the function is 0 at this point, which we can also see here graphically. But we can also calculate it. So if we insert the variable -1 into our function 3x plus 3, we get 0. So at this point, the value of the function is 0. And because we need to find when the values of the function are negative, we can say that when x is less than -1. Because, as we can clearly see here on the graph, that when the variable's value is smaller than -1, the values of the function are all negative. So, if we now look at another graphical representation of a function, f of x is -4x plus 2. And if we now look at the same question as before, we can see that the root of the function is now 0.5. So now, when the variable x is greater than 0.5, the values of the function are negative. So now, the next exercise is to solve the same question mathematically. So this is the same as -4x plus 2 is less than 0. And when we are solving linear inequalities, we solve it exactly as we would solve linear equations, but with one big exception, which I will explain later on. So if we now solve for this, we add -2 on both sides. So we get -4x is less than -2. And now, to solve for x, we divide both sides with -4. So now we have positive x here and 0.5 here. So here comes the important part. So as we divided by a negative number, the less than sign flips around to the greater than sign. So anytime we divide or multiply by a negative value, the sign here flips. Because if you just think about it, if we have, for example, -2 is less than 4, and we divide it by 2 on both sides, we get -1 is less than 2. So this still holds true when we divide or multiply by a positive number. But if we now were to divide this by -2, we would get 1 is less than -2. And clearly this is not true because obviously 1 is bigger than -2. So, therefore, the sign here need to flip around for this to hold true. So now 1 is greater than -2, which is true. So now, jumping back into our exercise, as we divided with a negative number, the sign here flipped. So x is greater than 0.5. And as we previously determined visually from our graph, this holds true. So when x is greater than 0.5, the values of the function are negative.